Welcome to series of database management system video lectures. Today we will be discussing about unit 5 topic 7, that is advanced topics of databases. So the first type of database we have here is parallel database. Now when it comes to a traditional database, we will have only one database server wherein the user can interact with it and perform any kind of operations such as creation, deletion, insertion, updation, all these sort of things can be done. Now, when we wanted to increase the availability of the system, then multiple number of users have to access to the same database. Now, while performing any query processing, we need a certain other set of memory components and the processor have to be execute each and every operation. So now, when multiple number of users are acting upon the same data element, so then we need to provide consistency of the data, right? By going with a locking mechanism or by going with a timestamp based protocol mechanism, so that we are going to ensure that there will not be any inconsistency of data. So if that is the thing that we are trying to implement, never you will be able to achieve efficient utilization of the resources. So that's the reason we want multiple number of databases, instances of the databases that have to be created in such a way that every instance of the database can be parallelly accessible to every individual user. Whatever may be the changes that have been implemented upon that data can be later on applicable to the original memory data. Okay, so this sort of requirement will fulfill a high availability of the data. Okay, so what are the main intention of going with this parallel database is nothing but to improve performance. Now, when multiple number of users are acting upon the same database, then we need to provide the resources in such a way that it should be always be accessible, available, and it should perform the given operation within a very less short response time. Right now, the third one is improve reliability. Now, what is the data that we are accessing should be the same thing that should be reflected to the users. And finally, we have distributed access of the data. When the data is being centralized, then only the set of users are accessible to this data. So maintenance of this sort of data will be a tedious job. In order to overcome with it, centralized database structure, from there we have moved on to distributed database. So this distributed database helps us to span across the whole world for accessing, and you will be able to perform the operations wherever you are. And that's how the updations are also going to be reflected, giving you high availability and going with a zero fault tolerant range. And finally, you will always be able to access to the data, providing high level of performance, right? So all these are the goals of the parallel database. Next is multimedia database. Now, from the term itself, we can understand that multimedia is nothing but a combination of text, images, audio, video, and various other file formats which have to be handled simultaneously. And to deal with this, we need to even have the inflow and outflow of the data rate provided with the internet connectivity. So all these should be kept together in order to develop a multimedia data. So in order to handle this sort of requirement, a normal traditional database may not be suitable. So we need a database which will be able to handle different types of media data. Different formats of data can also be processed, converted, and we should be able to identify a media keyword data through which you will be able to analyze what type of data and how the data is being generated and at what timestamp the data is being produced, what is the speed in which the data is being generated. And finally, media feature data will also helps us to derive the content which is being produced from the data. So if a feature extraction is being done, this can be further applicable to various other domain areas such as machine learning and then deep learning areas. Right. So in this manner, we should design a database which can handle with these contents. And what can be the different applications wherein multimedia databases can be more useful? The first one is repository application. Now, repository is nothing but a huge containers wherein it stores all the data which can be useful for any type of users, right? And this repository should be designed in such a way that it is capable enough to deal with any type of data which is being streamed or buffered or captured, right? Text, audio, video, any kind of, and even we need the compression techniques which are going to reduce the amount of storage which is being allotted. And next is presentation application. Now, the whole world is dependent upon the visualization of data. So whatever the data that we have, we need to present it in such a way that it should appeal each and every user. And most of the business enterprises will rely upon developing this kind of a high level of visualization of data. So we need a combination of various formats of data which has to be handled and to be stored at a later purpose, so that you will be able to retrieve it. Okay. And thirdly, we have collaborative working using multimedia information when we are dealing with one particular project. And we need to allot multiple number of people who can collaborate with each other, sharing parts of data which is being developed and for the exchange of data from one place to the other place with a smart way of techniques so that there will not be any loss to the data, right? So these are the application areas. Let us go to the last one. Yeah. And what are the challenges that we face when we deal with multimedia databases? The first one is modeling. Now, how do we design how a database container will be developed in such a way that it can store that data? So first, the data have to be modeled. Second is the design should be specified which type of formats that are going to be used for the storage of the data. And the third one is when it comes to the storage purpose, as we have already created a huge number of tables and then databases wherein we have just dealt with only textual data. Now it is the time wherein we need to handle with the different types of image formats and then audio formats and then video format. So database management system supports one data type, that is a blob, that is called as binary large object, which it supports the Excel data file format, an image format, right? So any type of data can also be stored in the database. That kind of provision should also be provided by the developers such that you will be able to store this multimedia data. So which technique will help us to reduce large amount of storage which is given for the data? There should be a different type of compression techniques which will reduce the overusage of the memory. Now, after allotting the memory, we need to even look at various other resources for the proper utilization, right? It should not have an impact upon the actual response which is being given by the processor, right? So it should not badly impact upon the actual execution environment. So how do we handle with a performance issue, though multiple number of users are dealing with the multimedia databases? Finally, how the queries have to be constructed and in what way the query engine will be able to understand and what can be the optimization techniques that are going to be implemented and how best the data is going to be retrieved from the multimedia database. So all these are the challenges which helps us to develop a very high level of multimedia databases. Okay. The next one is where these multimedia databases can be applicable. Yeah, the first one is document and record management. So now when you wanted to generate more number of documents, which is a combination of various types of data items, and then how do we extract a data in a record manner, right? So different records of data can be created, which is related to every individual, and all these have to be kept together, right? So in that context, multimedia database can be the best suitable one. And the next one is knowledge dissemination. Now, when we have collected as a data engineer or a data analyst, we will be dealing with a multiple number of data items which were continuously generated by various other social medias, and we need to collect all that data and which has to be facilitated in such a way that it can be accessible by any users for better understanding of the pattern of data, right? So we should always develop utility in such a way that at later point of time, people can also be able to learn something. They should get benefited by collecting this particular data, right? Yeah, next is education and training. The same point which we have discussed here with respect to knowledge dissemination. In the area of academics, each and every individual student have to be trained with various computer-aided learning materials. So that helps us for easy and better understanding of the concept, where they will be able to learn various patterns, which helps us to improve knowledge. So that's how we have the concept of digital libraries, wherein the huge repositories are going to be designed to store lots of data, which can be accessible by only the authorized users. And when it comes to marketing, advertising, retailing, and entertainment, travel domain areas, also multimedia data can be very huge requirement. And finally, we have real-time control and then monitoring. So when you wanted to perform a real-time applications for observation of data, so there will be a data which gets generated on a second basis, on a minute basis, on an hourly basis. So we need to have the control in such a way that you should be able to collect that data and have a close monitoring of data, that what were the changes which have been made from 1 second to the other second, right? So which helps us to have a very good cooperation among various teammates for developing new components for the machinery, which helps the mankind for developing fully automated environment. Okay. Now, the next type of databases are nothing but mobile databases. Mobile databases are totally different from the traditional databases. Here comes, we have a smartphone. This smartphone should be designed in such a way that it should also have a processor storage area, right? And this storage area have to be subdivided into various other file formats to be accepted, textual data, image data, video data, right? And which should also give a provision for setting up the internal operating system, right? So mobile storage will have a very less scope. You will have less amount of space, or the compact size of the data should be stored here in the mobile databases. So the challenging issues are nothing but within a small chip, you should be able to give the provision to store huge amounts of data. So what are the new technologies that have been available in the market? be updated to that, and then we need to develop this sort of databases. And next, the advantages of this mobile database is that every time we need not perform more number of cycles of operations with respect to CPU. Everything is embedded within the mobile device itself. And then you can even work on when you are on the way as well. That means mobility of the data is also provided so that wherever we are, we will be able to continue with our ongoing executions or handling with the data items. And second important point is that these mobile databases should always be synchronized, because when we are dealing with, let us take one example, social network application, WhatsApp, right? So when we have sent a message and here in the mobile database, if the changes were reflecting to be not read, then in the actual system also, it should display it with not read only. It should be synchronized properly. Only then it can be conveyed to the third person whether the messages are reached to the recipient have read or not. Okay. And then mobile databases requires very little support and maintenance because they always comes with a very smaller size, and we don't need to worry much about the space and then utilization of it. And it should be synchronized with a multiple number of devices such as computers, laptops, and then mobiles. When we are handling same application being connected from various other sources, then it should be synchronized and give a proper data. Now, if I have opened an email and I have read the content, and it should not display in the mobile that it wasn't read or it wasn't opened yet, right? So that sort of issues should be handled very carefully. And the drawbacks of the mobile databases is that which is less secure. That's the reason there are many number of applications. By just performing a single click, it is going to format the whole mobile data or the files which are available in the mobile, right? So we don't have that good security mechanisms in order to oppose from the high risks which are being generated. And then finally, mobile unit that houses a mobile database may frequently lose power because of limited battery. So now the charging of this particular mobile is also one of the important points, because unless this, you will not be able to perform any kind of operations. Next is web database. Now, unlike with the traditional databases wherein the data is completely centralized and all the other users were accessible to it, or various other organizations will also be connected through a LAN connectivity or through WAN connectivity. But then centralized issues have been totally resolved by going with a distributed databases wherein every other location, geographical location will have a replication of the data items, and that's how it will ensure that availability of data will always be high. Fault tolerance can also be done very easily, right? So in this distributed environment also, there are few kind of challenging issues. That is, we need to have clocks synchronized in almost all the other connected systems. And the second issue is that always it should be updated, right? So we need to perform a very high level of monitoring when it comes to a transaction management, whether the transaction was read committed or read uncommitted, right? So whether dirty loss has happened or not, each and every minute details should be verified for the web databases. Now, for the previous type of database. Now, with respect to web database, let us not have that infrastructure which is being installed on the local machines. Though we don't have that database software which is available, but then also we will be able to perform the operations by pushing everything onto the cloud, which helps and which helps all time accessible, and then provides a lot of security going with the proper user credentials. And there are various types of web servers and middleware technologies that have been used in the background, which helps us to design a web database which can be accessible by anyone from anywhere with a limited number of infrastructure. This helps us to reduce worry about the infrastructure and memory requirements and then processor requirements. If the applications have been built on this kind of web databases, all the data can be transferred in terms of the objects from the sender to the receiver, providing high level of security, which can be exchanged from one place to the other place. To do that, we need a middleware technologies. They are CORBA, Internet IO protocol, and then RMI, remote method invocation, XML, which is going to be used when we wanted to communicate from one application to the other application, wherein the designing issue was totally different. Right? For the exchange of data between any two different applications, we can use XML. And we have various other web services such as SOAP and then UDDI. All these are the middleware technologies which helps us to perform communication over the web databases. And then next we have online OLTP and then OLAP, online transactional processing system and online analytical processing system. Transaction processing system will be dealt with only the operations that are going to be restricted to that particular transaction. Analytical processing is nothing but it It will have a track of how many number of operations that are being done by taking how much amount of time, by utilizing how many number of resources, right? Everything is going to be analyzed in detail. Now, OLTP focuses more on insertion, updation, deletion from the database, whereas OLAP, it simply extracts the data for analyzing that helps in better decision making. So what can be the query that have to be framed in such a way that which is going to give an optimal result with a very less access and response time. Now, dealing with the data, OLTP and its transactions are the original sources of the data because these are the data items which are going to be generated when multiple number of transactions which are processed. Then in OLAP, different OLTPs databases become the source. Yes, we consider various OLTPs to find the pattern and how the data can be mined and what can be the algorithms that are going to be used to retrieve to that particular data. And then transaction. OLTP focuses only on the transactions, and then it will always have it will consider only the small transactions should be processed fastly. And OLAP has very lengthy transactions because it has to analyze every detailed information. And then when it comes to OLTP, the processing time of transaction is comparatively less. Whereas here it involves more time because it has to perform a detailed analysis. For OLTP, we write only simple queries, but then for OLAP, we go with complex queries, which involves various other SQL operators, going with the subqueries, going with the joins, grouping of various other data items. That's how you will be able to fetch the data. And in OLTP, the normalization of databases can be applicable till third normalized forms only. Whereas in OLAP, the databases are never going to be normalized because unless we don't have a repetition of data, we will not be able to know that how the flow is being done. For to-do analysis, we definitely need the repetition of the data items. Then finally, in OLTP, the integrity must be maintained. Data integrity is ensured. Whereas in OLTP, databases do not get frequently modified because we just store the once the data which is being stored, we just take it for the analysis part. We will not do any kind of changes to it. So that's why we need not give high priority to the data integrity. We are not going to violate any data integrity principles there. So that's the reason it will not have any impact upon it. And next, we have NoSQL databases. We have two categories here. The first one is a SQL database, and the next one is NoSQL database. Here in SQL database, all the commands have to be learned, only then you will be able to perform the operations. Whereas in NoSQL database, we need not remember majority of the commands to perform any kind of operations. Okay, so NoSQL databases always follows the pattern of a relational databases, wherein it stores the data in terms of tabular format, whereas in NoSQL databases, we have different techniques to store the data. Yeah. So these are the NoSQL databases, that is column, family, graph. It represents the data in column, family, graph, and document manner, and finally key and value base. In this manner, you will have a different representation of data items which can be stored in a different manner for the purpose of easy accessibility to the data, processing of it, and then fast retrieval of the data items. Now, NoSQL databases advantages are nothing but high scalability and high availability. So the problem which was encountered with respect to NoSQL databases where you don't have a lot of focus on that particular issue which has been encountered, and then which is NoSQL databases are always open source because to encourage the usage by everyone. And there are many management challenging issues that we have because different users will store the data in different format. So no one follows a unified format. So dealing with that set of data will be a tedious job, and GUI is also not available for this NoSQL databases, and always it may not promise us to have a very good backup, but then it attempts to give up to a certain extent, and it supports large document size, whereas SQL databases will not support this sort of thing. Okay, so that's the reason. Then depending upon the next generation of our data which is being exponentially growing, we need a kind of containers which helps us to store the data even without streaming or even without putting into a one particular structure, right? So with this, the last part of the unit 5 is completed.